Have you ever stumbled upon some confusing JavaScript code and wondered what on earth it means? You're not alone. Today, we're diving into a tricky expression that evaluates to A in JavaScript, and I promise it's going to be enlightening. I totally get it. Obfuscated code can feel like trying to read a foreign language. Many developers have faced the same frustration when trying to decode complex expressions. You're definitely not alone in this. Let's take a closer look at the specific question at hand. One user asked, why does the expression plus, plus, plus evaluate to A in JavaScript? They also wondered if there are other snippets to get different letters. Sound familiar? Let's break it down together. So, what's happening in this expression? It involves some interesting concepts like type coercion and the way JavaScript handles truthy and falsy values. Understanding these concepts will help us decode this expression. And stick around. By the end of this video, you'll not only understand why this evaluates to A, but you'll also learn how to manipulate similar expressions to get other letters. To understand why the expression evaluates to A, let's break it down step by step. First, the user should look at the part plus. This converts an empty array to a number, which results in 0, and then the double negation converts it to false. Next, the user should consider the expression. This converts a non-empty array to true. So now we have true and false from the previous steps. Now let's combine these results. The user has false from plus plus and true. When we concatenate these Boolean values, we get false plus an empty string, which results in the string false. Next, the user should look at the expression plus small p. Here, evaluates to 1, which means we are accessing the first index of the string false. This gives us the character at index 1, which is A. Finally, the user can experiment with similar expressions to get other letters. For example, changing the index can yield different characters from the string. Fun fact, JavaScript is known for its quirky type coercion rules. Sometimes it feels like JavaScript is playing a game of hide and seek with data types. Now let's look at the answers provided by other users. This user explains that understanding operator precedence and typecasting in JavaScript is key. They point out that the expression starts with plus, which evaluates to false. When you concatenate false with an empty string, it becomes false. Then they highlight that false at index 1 gives us A. That's it for that response. Let's explore another one. This user explains that to understand why the expression evaluates to A, we can break it down step by step. First, typing an empty array plus an empty string gives us an empty string. Then the expression plus evaluates to false, which when converted to a string becomes false. Next, we access the character at index 1 of the string false, which is A. Finally, they clarify how Hall evaluates to true, and when converted to a number, it gives us 1, confirming that the character at index 1 is indeed A. That's all for that response. Let's see what someone else had to say. This user explains that the expression evaluates to A due to JavaScript's implicit type conversions. When you add a number to a string, JavaScript makes a guess instead of throwing an error, unlike C++. They break down the expression into two parts. The first part evaluates to false, and the second part evaluates to 1. So when you access the first index of false, you get A. That's it for that response. Let's explore another one. This user explains the evaluation of the expression step by step. First, the unary plus converts an empty array to 0. Then, applying double negation to 0 gives false. Concatenating false with an empty string results in the string false. Next, the expression accesses the second character of false, which is A. This process highlights JavaScript's implicit type conversion, also known as type coercion. Here's a little bonus for you. You can create similar expressions to get other letters by manipulating the array and the indices. Experimenting with these can be a fun way to learn more about JavaScript. And there you have it. You've cracked the code behind why that expression evaluates to A. Keep exploring and experimenting with JavaScript, and if you found this video helpful, don't forget to subscribe for more coding insights.